All right, let's look at part 4 of the U-Substitution series, but this time it'll involve definite integrals, and really nothing changes in this except we have to have one more step. The way we start out will be exactly the same that we've done in the first 3 U-Substitution series, so if you haven't watched those yet, I would suggest you start with those. But let's try this and see what happens here. Okay, my first step here is to make a choice of U, so my choice of U is going to be what's inside the parentheses, so that will be U. And just like on the previous problems, once I've made a choice of U, I'll go ahead and rewrite this thing from 0 to 1, and I'll put my choice of U on the left-hand side, so x squared plus 1 raised to the 3rd power, and I'll take this x, and just like I've done before, I'll move it over to the right-hand side. So that's going to give me an x dx. Okay, now what I've got to get rid of is going to be this part right here, what's inside the black box. And my choice of U is what's inside the parentheses. So follow the same steps that you've done before. Let U be equal to x squared plus 1. Find the derivative of that, so du dx will be equal to 2x. That means that the differential of U would be 2x dx. Now look back at your box over here. You need an x dx, you've got a 2x dx, so take this 2 and move it to the bottom on this side. That'll get you to a 1/2 du is equal to x dx. Now finally, that means that this one agrees with this one up here. You needed an x dx and you've got an x dx, so trade it out for this thing right here. So that's going to be my U-substitution. Again, just like I've done in the previous problems, I'm going to go ahead and put a little box around this to isolate it from the rest of the problem. So what's in this red box here is my U-substitution. So that is the U-substitution. Now what that'll do to the problem, it changes it into this right here, the integral. And in place of this, I'll put U cubed, and then in place of the x dx, I'll put what it's equal to, which is 1/2 du. Now with definite integrals, here's the one thing you've got to change. You've changed the problem from an x problem into a u problem. Now up here originally, these are x limits. This goes from x equals 0 to x equals 1. Now if you change the problem from an x problem into a u problem, then you also have to do this. You've got to change the limits to u equals something to u equals something. So not only do you have to change the inside part of the problem, but you've also got to change the limits. Now the way to do that is this. When x is equal to something, u is going to be equal to something, and it comes from this right here. I'll put it under blue. So use the fact that u is equal to x squared plus 1. So start with the top one. I'll do the top one first, and I'll do the bottom one. So when x is equal to 1, then u is equal to, and plug the 1 into this thing over here, x squared plus 1. So plug a 1 in, squared plus 1, which is going to give you 2. So when x is equal to 1, u is equal to 2. Now, do the same thing for the bottom limit. So when x is equal to 0, u is equal to, and plug a 0 into this thing. So 0 squared plus 1, which gives you 1. So these are going to be your new limits, and this time I'll go ahead and put a little blue box around this. So this is going to be from here Okay, now what this is, in the blue box, this is where I change the limits. So what this is going to do, it's going to go from when x is equal to 1, u is equal to 2, so put a 2 right there. When x is equal to 0, u is equal to 1, so put a 1 right there. So you've changed it, the entire thing, from an x problem into a u problem, including the limits. Now just go ahead and solve this. So first of all, bring the 1/2 out in front. So it'll be 1/2 the integral from 1 to 2 of u cubed du. Well, what that'll be would be 1/2, and then the antiderivative of u cubed would be u to the 4th divided by 4, evaluated from 1 to 2. So now we'll come down here. This will be 1/2 of, and first of all, plug in the 2. So that's going to be 2 to the 4th divided by 4. And then that's at the top limit, then minus, now evaluated at the bottom limit, 1 to the 4th divided by 4. So plug in the top number, plug in the bottom number. And what that's going to give you is 1/2. This will become 16/4. So 2 squared is, or 2 to the 4th is 16/4, minus this will be 1/4. And what that's going to be would be 1/2 of, now 16/4 minus 1/4 would be 15/4. And finally multiply the two denominators together and you would get 15/8, and that's going to be the answer to the problem. So really the only new thing here is to add this step where you change the limits. So rather than having x equals something, change it into u. So change the entire problem, including the limits, from x into u. Okay, with that in mind, let's take a look at a couple more examples here. Now on this one, the very first step on this one, I'm going to go ahead and take what's in the denominator, it's to a positive 2 power. I'll move it to the numerator and make it be to the negative 2 power. So I'll change this into the integral from 1 to 2 of, I'll put it in parentheses, 3 minus 5x, the entire thing, to the negative 2 power dx. Okay, now with that in mind, my choice of u is going to be what's inside the parentheses, so this is what I'm going to have to get rid of right here. And my choice of u will be what's inside the parentheses, so there's u. So just like you've done before, first of all, go ahead and find the derivative of the u term. So this is going to be 3 minus 5x. So the derivative of u with respect to x would be, the derivative of constant is 0, this will turn into a negative 5. That means that the differential of u would be equal to minus 5 times the differential of x. Now looking back over here, all you need is a dx, you don't need this negative 5, so move it to the bottom on this side. So that becomes negative 1/5 du is equal to dx. Well, now you've got what you needed. You needed a dx, and you've got a dx all by itself. So trade it for what it's equal to, and it will be equal to this thing right here. So let's stick that in a little red box just to separate it. So here's the U-substitution part of the problem. So there is my U-substitution. Now what that does, that gets me down to this. That gets me down to the integral. And this becomes u to the negative 2. And I'm going to replace the dx with a negative 1/5 du. Now once again, just a reminder, when it was in this form, these are x limits. This is from x equals 1 to x equals 2. So what I want to do, I want to change it into u limits, so I need u equals something to u equals something. So I'll use the same thing. I'll use this to find out what those things are. So u is equal to 3 minus 5x. So what I've got, I'll start with the top limit. So when x is equal to 2, then u is equal to, and plug a 2 into this thing right here. So 3 minus 5 times 2. Well, that would be 3 minus 10, which would be a negative 7. So now find the bottom limit. When x is equal to 1, then u is equal to 3 minus 5, and plug in a 1. Well, 3 minus 5 would be negative 2. So there are my new limits, and I'll stick a little box around those. So these are the new limits. So what that means is that I'll evaluate this from, now again, keep them in order. Sometimes it changes. It's like Normally the smaller number is on the bottom, but it's possible when you do this they may reverse and the smaller number may be on the top. Well, when x is equal to 2, u is equal to -7, so put the -7 right there. So the top limit goes with the top limit, the bottom one goes with the bottom. When x is equal to 1, this is equal to a -2. Now it's just a matter of evaluating that integral. So again, I'm going to take the -1/5 and bring it out in front. So this will be equal to a -1/5 of the integral from -2 to -7 of u to the -2 du. Okay, what that'll give you would be -1/5. Now again, add 1 to this, this will change into u to the -1 divided by a -1, evaluated from -2 to a -7. Okay, now we'll bring it back over here. So -1/5 of, and go ahead and plug in the top number. Well, actually, I'll do one more step here first. This will make it a little bit easier. Let's take this u to the -1, bring it to the bottom, make it be u to the +1. So that's going to give me -1/5 of, now, u to the -1, bring it to the bottom, it makes it u, and then I'll take this negative and move it up on top. So it really turns into that right there. So -2 to -7. Makes it a little bit easier to solve. So now plug in the numbers. So first of all, plug in the top number. So you've got -1 divided by a -7. Then minus, plug in the bottom number. And this is going to be a -1 divided by a -2. Okay, now the negatives will cancel out, and that's going to leave you with this. -1/5 of, this will turn into 1/7 minus 1/2. Now I'm going to get both those over a common denominator. So a common denominator would be 14, so I'll multiply this one by 2/2. Multiply this one by 7/7, just to get them to a common denominator. So what that's going to give me would be -1/5 of, this becomes 2/14 minus 7/14. That gives me a -1/5. And go ahead and put these two together. So 2 minus 7 would be -5/14. And in this case now the 5's cancel out. And also the negatives cancel out. So the final answer would be 1/14. So the final result would be 1/14. So there's a second problem. Again, make sure that change the limits. So change not only the problem from x in terms of u, but change the limits from x limits into u limits. All right, let's take a look at a trig example. If you have a problem like this, now on this problem, it's not the sign of a simple x. So since it's a composite function, you're going to have to let u be equal to the argument of the trig function. Now in this case, it's set up where all you'll have to do then is let this is your dx term. This is what you're going to try to get rid of. So let's start out like we've always done, first of all, working with the u. So u is equal to 2x. So the derivative of u with respect to x would be equal to 2. So the differential of u would be equal to 2 dx. Again, I need a dx and I've got a dx, but I don't need the 2, so I'll take the 2 from this side, move it to this side. That gets me to 1/2 du would be equal to dx. Again, just like in the previous problems that we've done, I needed a dx and I've got a dx. So that takes care of that. And I'll trade it out for what's inside this circle. So there's my U-substitution. So again, we'll stick this and kind of isolate it. And that is the U-substitution. So what that does, it changes the problem into this. The integral, this would be the sine of u, and in place of dx put what it's equal to, which would be 1/2 du. Now once again, same old thing, you got to change the limits. Easy step to forget. Right now this goes from x equals 0 to x equals 2. Well, what we want to do is change it from u equals something to u equals something. So you got to get the whole thing in terms of u. So again, to do that, I'll use the fact that u is equal to twice x. So starting with the top limit, when x is equal to pi divided by 2, u would be equal to twice pi divided by 2. So just plug a pi divided by 2 into this. And what that gives you is pi. Then evaluate the lower limit. So when x is equal to 0, u is equal to 2 times 0, which is 0. So there are your new limits, and we'll isolate those with their own little box also. So there are my new limits. And what that means is I'll now evaluate this thing from x equals 0 to x equals, or from u equals 0 to u equals pi. Again, keep them in order. Top one goes with the top one, the bottom one goes with the bottom one. And now it's just a matter of evaluating this antiderivative. So again, I'll take the 1/2 and bring it out. Take the 1/2 here and bring it out in front, which gets me to 1/2 the integral of the sine of u du evaluated from 0 to pi. So that goes 1/2. Now the antiderivative of the sine is the negative of the cosine. And I'll evaluate that from 0 to pi. So now I've got 1/2 of, and first of all, go ahead and evaluate the top number minus the bottom number. So I'll put this in parentheses, minus the cosine of pi. That's the top number. Now plug in the bottom number, minus the cosine of 0. So it looks like that. Now what this one's going to be, this would be 1/2 of, now I've got the negative of, the cosine of pi is a -1. Then minus the negative, the cosine of 0 is 1. So what that gives me is 1/2 of, now two negatives make a positive, that'll turn into a 1, and this turns into a 1. So it's going to be 1/2 of 2, and the 2's cancel out and leave you with a 1, so this final answer will just be equal to 1. So there's a trig example for you. But again, still just remember, use the normal U-substitution, and then remember to change the limits from x limits into u limits. Let's work one more just to kind of show you how sometimes the definite integrals actually can be shortened and save you some work. Okay, let's try this one. Now what I'm going to do is, again, my choice of u is going to be what's inside the parentheses. So that'll be the choice of u. So I'll rewrite this as the integral from -1 to 1. My choice of u I'll put on the left-hand side. And I'll take this x and move it over here, which gets me to an x dx. Okay, now I'll do it just like we've done all the other problems. We'll go ahead and start with this. Let u be equal to this. So let u be equal to x squared plus 1. So du dx would be equal to 2x. That means that the differential of u would be 2x dx. Again, I need an x dx and I've got a 2x dx, so I'll move the 2 over here. That gives me 1/2 of du is equal to dx. Now, I needed a dx and I've got a dx, So I'll trade it out for this thing right here. So there's my U-substitution, a little quick box around that. So there's my U-substitution. Now, what that gets me to is this. It'll be the integral of U cubed, and then in place of dx, put what it's equal to, 1/2 du. But again, let's change the limits. Remember, this is from x equals -1 to x equals 1. Well, what we want is from u equals something to u equals something. So here I'll change the limits. So starting with the top limit, when x is equal to 1, u is equal to, and plug a 1 into this right here and see what u is. So it would be 1 squared plus 1, which is 2. Now the lower limits. When x is equal to a -1, then u is equal to, plug in a -1 squared plus 1, which is also equal to 2. So there are my limits, the new limits in terms of u. So there's where you change the limits. But now in this problem, watch what happens. When you plug these limits in, you're going to evaluate it from 2 to 2. Now on any function, whenever you evaluate it, if the limits of some function f of x go from a to a, then the interval has no width, and the answer is going to be 0, because you wind up with a minus a, which would be 0. So if these two limits are the same, you can actually stop right there, and the answer to the problem is going to be 0, because they have the same limits. So in this case, you don't even have to finish the problem out, because if the upper limit is the same thing as the lower limit, then the integral has to be 0. So there's one final example for you. But just remember, whenever you're working with definite integrals, not only change the problem from an x problem to a u problem, but change the limits from x limits to u limits, and everything works out fine.